Flare has just introduced a breakthrough for XRP users, the ability to keep XRP on the XRP Ledger while using full smart contract functionality on Flare. This is a shift that redefines how we think about programmability on the XRP Ledger, and it does so without compromising the core design principles of the XRP Ledger itself. Imagine this scenario. You own XRP, and you want to use it in a programmable, smart contract-enabled system. Traditionally, that would mean moving your XRP to a blockchain with native smart contracts, or perhaps wrapping it up in some other tokenized format. But with Flare's new model, XRP stays where it is, on the XRP Ledger. The smart logic, the advanced features, the automated flows, all of it happens on Flare, without ever leaving the XRP Ledger. This presents a paradox that most people still find hard to grasp. If XRP doesn't have native smart contract functionality, how can it be programmed in this way? How can smart logic be applied to an asset without moving it? It seems counterintuitive, but that's exactly what this new development promises to unlock. And this is where the confusion starts. When people hear Flare adds smart contracts to XRP, many automatically think this means wrapping XRP or using a bridge to move assets around. But in reality, nothing of the sort happens here. Flare uses a messaging system to allow the XRP Ledger to interact with Flare's smart contracts. No wrapping, no moving of assets. In this video, we're going to break this down. We'll show you how Flare accomplishes this without changing the XRP Ledger's core, minimalistic design, and why this could be a game changer for institutional adoption and real-world tokenization. Let's dig deeper into the mechanics of the system. How does Flare work, and why does it matter that XRP stays on the XRP Ledger while its logic runs somewhere else? Everything here is for educational and entertainment purposes only, not financial advice. Always do your own research before making any investment decisions. If clear, no hype crypto education helps you make sense of all this. Hit like and subscribe. It tells YouTube this series is worth showing to other newcomers, and it helps me keep building it for you. To understand why this new model is significant, we first need to appreciate why the XRP Ledger has always been different. The XRP Ledger was built from the ground up as a settlement engine, not a platform for smart contracts. It's designed to be fast, deterministic, and scalable, a ledger that can handle high transaction volumes reliably and securely. For years, many have said that XRP Ledger doesn't need smart contracts. And for good reason. Every added feature typically compromises the performance, reliability, and simplicity of a settlement layer. If the XRP Ledger were to add native smart contract functionality, would it compromise these benefits? Could you still have the best of both worlds? That's the central tension here. Users want programmability, but institutions prefer XRP Ledger's minimalism. How do you add programmability to the XRP Ledger without disrupting its core design? Flare answers that question. Instead of integrating smart contracts directly into the ledger, Flare uses a message passing system. This allows you to keep your XRP where it belongs, on the XRP Ledger, while executing smart logic externally on Flare. It's this innovative separation of concerns, settlement on the XRP Ledger and logic on Flare, that gives us the flexibility to scale programmability without sacrificing the reliability of the settlement layer. A Flare Smart Wallet isn't a traditional wallet in the sense you might be used to. It's an authorization and execution layer that interacts with both the XRP Ledger and Flare. Here's how it works in simple terms. Your XRP stays on the XRP Ledger under your control. You authorize a Flare Smart Wallet to interact with your XRP Ledger account. When you want to run smart logic, whether it's a conditional payment, automated treasury action, or smart escrow, the Smart Wallet sends the request to Flare. Flare executes the logic inside its smart contract environment and verifies the outcome. The result is sent back as a message to the XRP Ledger, which then executes the final settlement. No moving of assets, no bridging. Just authorization and message passing. The XRP stays where it is, and the logic runs externally, safely, and securely on Flare. This method allows Flare to provide smart contract functionality for XRP users without any of the risks traditionally associated with bridges or external custody solutions. One of the most important distinctions here is messaging versus bridging. Bridges move assets and typically take custody of them. They carry risks because they rely on liquidity pools, lockups, and centralization. Messaging, on the other hand, doesn't move the asset. Instead, it passes state information between two systems. Flare doesn't take custody of your XRP. It simply receives messages about the state of your XRP Ledger account, executes logic based on that information, and sends the results back to XRP Ledger for settlement. This separation of concerns is crucial for both security and institutional adoption. Messaging-based interoperability eliminates the need for trust assumptions about asset custody, making it a far safer choice for regulated institutions. Flare's FXRP model was the first iteration of bringing XRP into a smart contract environment. FXRP worked by creating an over-collateralized representation of XRP on Flare, allowing users to interact with smart contracts, but it required wrapped assets and external collateral providers. That design raised concerns for larger institutions, especially around custody risk and collateral management. The introduction of the FAssets system marks a shift toward a more flexible model. FAssets still rely on over-collateralization, but they no longer require moving XRP off the XRP Ledger to be useful. Instead, Flare uses its data layer and message passing architecture to reference the state of XRP on its native ledger, enabling far richer interactions without traditional bridging. This approach makes FAssets more transparent and auditable, while reducing many of the operational hurdles that limited earlier cross-chain designs. It's this architecture, collateralized synthetic assets paired with a messaging system, that enables Flare's smart wallet model to interact with the XRP Ledger in a safer, more modular way. So how does this become accessible to regular users? That's where Uphold comes in. Uphold is the first major exchange to integrate Flare's messaging system, enabling XRP holders to interact with Flare's smart contracts without leaving the XRP Ledger. In simple terms, here's how it works. You keep your XRP on the XRP Ledger. When you want to initiate a smart contract action, Uphold facilitates the interaction by routing your request to Flare. Flare then executes the logic and sends the result back to the XRP Ledger for settlement. Uphold's role is crucial because it simplifies the process for users. They don't need to be blockchain experts to leverage advanced smart contract functionality. Uphold turns a highly technical system into something accessible, offering a seamless experience for both retail and institutional users. This integration also has significant compliance benefits. Uphold is a regulated exchange, meaning that it operates within strict legal frameworks for anti-money laundering, AML, and Know Your Customer, KYC processes. When an exchange like Uphold integrates Flare's messaging system, it bridges the gap between regulated custodial financial systems and decentralized smart contract features, creating a new layer of trust and accessibility for users. What does all this mean for institutions? We've already established that Flare's system offers programmability without leaving the XRP Ledger, but what does this really enable? First, consider programmable escrow. Typically, escrow services are used by institutions for trustless, timed releases of funds. But with Flare's smart wallets, that logic can become dynamic. Institutions can set conditions for the release of funds, like time-based triggers, or even automate the entire process based on external data, such as asset prices or market conditions. Second, think about corporate treasury operations. Large businesses manage vast amounts of capital that need to be moved, converted, or rebalanced quickly. With Flare, these companies can automate some of these actions. For example, they can set up automated hedging strategies or ensure that funds are reallocated across different accounts without manual intervention. Smart logic makes these processes smoother and faster, reducing overhead costs and mitigating human error. Then, consider the world of real-world asset RWA interactions. Tokenized real estate, bonds, and other assets require specific workflows to manage redemptions, transfers, or other operations. Flare's smart contracts can automate these flows without moving the underlying asset away from its native ledger. By using the messaging system between the XRP Ledger and Flare, institutions can create more efficient operations for these tokenized assets, whether for individual investors or entire financial networks. Lastly, there's compliance. With the ability to include checks for KYC and AML compliance, smart wallets can integrate seamlessly with regulated institutions. This means that banks and other financial entities can perform on-chain transactions while maintaining strict regulatory adherence. By enabling this kind of programmable compliance, Flare opens the door for more regulated institutional activity on the XRP ledger, something that would be a challenge for many other blockchains. There are a few different ways to add programmability to the XRP ledger, and it's important to understand where Flare fits into this landscape. The first approach is hooks. These are small, lightweight pieces of logic that run directly on the XRP ledger. They're designed to perform very simple tasks, such as conditional payments or adding small checks before transactions settle. While they offer programmability, hooks are still extremely minimal and don't support complex smart contracts. Then there's Xahau, a new chain designed to work with the XRP Ledger, but with a focus on deep programmability. It's a hooks-first chain, meaning it's built to integrate with the XRP Ledger while offering more features than hooks alone. However, it's still part of the XRP Ledger ecosystem, using the same consensus model and its inherent reliability. Next, we have the XRP Ledger EVM Sidechain. This brings full Ethereum compatibility to the XRP Ledger, enabling Ethereum-based smart contracts to run on a sidechain. While it's a powerful tool for developers who want to bring Ethereum-style programmability to XRP, it requires moving assets between the main XRP ledger and the sidechain, creating potential friction for institutions that prefer to keep everything on one ledger. Flare is different. Instead of integrating smart contracts directly on the XRP ledger or adding a sidechain, it allows execution off-ledger. Using the messaging system, Flare interacts with the XRP ledger without moving XRP, offering the full flexibility of smart contracts without requiring the XRP ledger to change its structure or reliability. So, while the XRP ledger has several ways to enable programmability, Flare's unique model offers the most flexibility for institutions that need complex smart contracts, but without sacrificing the trusted, reliable settlement layer that the XRP ledger provides. Flare's smart wallet architecture doesn't just open the door for simple transactions. It also unlocks a future for tokenization and yield strategies in a way that the XRP ledger hasn't seen before. By enabling programmable settlement, the XRP ledger can now facilitate more complex operations like tokenized treasuries and automated yield generation. Imagine tokenized government bonds or money market funds that require on-chain execution of specific rules before they settle on the XRP ledger. This could include things like dynamic rebalancing, automated conversions between assets, or scheduling payments based on market conditions. With Flare, all of this can be done without having to move assets off the XRP ledger or compromise on compliance. The system can automate and streamline yield generation strategies across multiple assets and networks, providing a seamless flow between different ecosystems without ever disrupting the core functionality of the XRP ledger. Moreover, because everything stays on the ledger, from settlement to smart contract execution, the model allows for advanced programmability while maintaining the security and scalability that the XRP ledger is known for. This is the next step in the evolution of tokenized finance. The key takeaway here is simple but profound. Flare allows smart contracts and programmability to exist on top of the XRP Ledger's settlement layer without disrupting it. The XRP Ledger remains exactly as it was designed to be: minimal, reliable, and fast, while Flare provides the programmability that many users and institutions want. By keeping these two functions separate but connected through messaging, Flare has created a smart, scalable way to enhance the XRP Ledger without ever changing its core architecture. This is a vision for the future where the XRP Ledger stays at the center of institutional financial flows, but its capabilities are extended with smart logic and complex contract automation when needed. As the world of tokenized finance grows, systems like this are the ones that will allow blockchains to integrate into mainstream finance without compromising on regulatory oversight, security, or speed. And it brings us to a final thought. If systems like Flare and the XRP Ledger continue evolving in parallel, which capability do you think ends up shaping adoption the most? The speed of settlement, the flexibility of smart contracts, or the interoperability that ties everything together? Thanks for watching, and I'll see you in the next deep dive. This channel is for educational and entertainment purposes only, and is not financial advice. Always do your own research and keep the discussion respectful. If you enjoyed the video, please consider liking, subscribing, leaving a comment, or sharing it with a friend.